Okay, we're asked to differentiate this expression here. Before we do that, the first thing that we need to do is actually write all the x terms in index form. So that's, I'm going to write it as y equals, instead of 4 root x, I know that that's x to the power of a half, so it's 4x to the power of a half. Plus x over 3 is fine, it's only the 3 that's the fractional part. This is x to the power of 1. We need to be careful here, but we have minus 1 over x squared. Well, to get the over x squared bit, we have x to the power of minus 2. Because it's one of them, I don't need a number in front. But now, all these x's are in index form, and we can now differentiate. So dy by dx is equal to, we'll multiply through by the power, so a half times 4 is 2, and reduce the power by 1, x to the minus a half. Just be careful, a half minus 1 is minus a half. Plus, you should know that when you differentiate an x term, you just get the number that's the coefficient of it, the number in front of it, or the number of x. Well, this is 1/3 x, so that's, when I differentiate, I just get 1/3. And for this one here, when I multiply through by the power, minus times minus 2 is plus 2. Be careful when you reduce the power by 1, though. Minus 2 subtract 1 is negative 3. And we should be okay, we'll get full marks for that. However, we should be confident enough to return these back into fractional form, because sometimes that can be very useful. X to the power of minus means 1 over x to the power of a half. So that's over x to the power of a half, and I know that x to the power of a half is root x. Now that would be x to the minus a half would be 1 over root x, but we've got 2 of them, so it's simply 2 over root x. Plus 1/3. Again, x to the minus 3 is over x cubed, but that's 1 over x cubed. We've got 2x to the minus 3, so it's 2 over x cubed. Again, if you're doing this in exam, you'll probably get full marks for this, but if we needed to use this expression in any future parts, then this is much easier to deal with, this is much easier to work with and to put values of x in. Okay, but like I say, this one here will get you your full marks in the exam. Part 2 then, or part B, asks for find the equation of a tangent to the curve. Now, the equation of a tangent we know is if you have a curve and you have a point on the curve, tangent is the line that just touches that. So to get that equation, we need the gradient at that point, and we need the actual point as well, xy. Well, let's first of all get the coordinates of the point. We know x is 2. Well, if x is 2, y is equal to, well, it's whatever we get when we put 2 into this equation. That's 4 times 2 cubed is 8, minus 6 times 2 squared, plus 10. So y equals 32, take 24 plus 10, y is equal to 18. And so the coordinate that we're going to use is x is 2, y is 18. The gradient, we should know though, the gradient of this line is the same as the gradient of the curve at any point. And to find the gradient of the curve, we find dy by dx. We differentiate the equation of the curve. Again, this box here. So multiply through by the power, reduce the power by 1. That's 12x squared minus 12x. And when I differentiate 10, I just get 0. When you differentiate a constant, you get 0. So there's our gradient. If x equals 2, then dy by dx is equal to 12 times 4 minus 12 times 2, which is 48 minus 24, which is 24. So I know that the gradient, I'm going to call it m, is 24. So let's now find the equation of this tangent, the equation of that line. And the equation of any line we know is y equals mx plus c. So we need some way of getting this value of c. Well, let's fill in everything we know. We know that at a point xy, we have a gradient of m. So when y is 18, the gradient is 24, and the value of x is 2. So 18 is equal to 48 plus c, so c is minus 30. And so our final thing, let's rewrite the full equation of the line. Y equals, I know the gradient is 24, x, and I know this value of c is minus 30. And so we've got the equation of the line. Y equals 24x minus 30. Finally, in this part, we're asked to find the range of values for which that function is increasing. If it's increasing, it just means that the graph is going up from left to right. But another way of thinking of that is that it has a positive gradient. Well, how do we find the gradient? Well, if f of x is 2x squared minus 3x plus 4, then the gradient is f dashed of x, and that's 4x minus 3. But if I want that for increasing, I know that the gradient, f dashed of x, must be greater than 0. It must be a positive gradient. So we can say that 4x minus 3 must be greater than 0. The gradient is positive. Well, 4x is greater than 3, and so x is greater than 3/4. And so we have found the range of values for which that function is increasing.